Hello, everyone. My name is Ibrahim, and this is my paper review for the performance analysis of machine learning approaches in stroke prediction. According to the World Health Organization, in every year, 15 million people are suffering from stroke worldwide, and affected individuals are passing away every 4 to 5 minutes. The goal of the paper review was just to find a machine learning model which can help detect if an individual is prone to getting a stroke or not. Finding a model is helpful in that it can help prevent permanent damage or death. It can help in early detection and management of the stroke disease to minimize the further damage in the affected area of the brain. Now on to the research methodology. The data was collected from the medical clinic in Bangladesh. The dataset contained 5,110 rows and 10 attributes. Stroke was our target variable. Age, gender, hypertension, work type, and residence types were some of the attributes that they used in the dataset. The models that the research used were 10 machine learning classifiers, and they are logistic regression, Gaussian classifier, AdaBoost classifier, and XGBoost, just to name a few. Now you may be asking, why are they using so many models? And in this case, there are 10 of them. Well, it's because they are all well-known classifiers and building vulnerability predictors. Something I found interesting was their procedure of stroke prediction. First, they dealt with their input data, which is their original data set. Then they went on to data pre-processing. They were checking for some missing values and duplicates. Then they went on to splitting the data into training and testing sets. Next, they went on to having base algorithms, which were the 10 algorithms as a base algorithm to train and test each approach. In the testing set, they had 1,556 data points. Next, they went on to weighted voting, and they used this to improve the accuracy of all the classifiers after their implementation of the base algorithms. Next, they used model optimizations and classification reports just to see and measure each model and find out the value of their precision, recall, F1 score, AUC, FP rate, and FN rate. Then they just concluded with a best model. This is just a graphical representation of the procedure for predicting stroke of different algorithms step by step. Now on to the results and findings. First, the results. So first, the research created a correlation matrix, and the research found that gender, age, hypertension, heart disease, average glucose level, BMI, and smoking status had high effects on stroke. Next, they looked at what predictors had a low effect on stroke, and that is ever married, work type, and residence type. As you can see, for the high effect, age has an effect of 0.99. That's a really high correlation to stroke, high effect on stroke. Ever married, on the other hand, has a negative 0.68, and that is, weakly correlated to stroke. Next, they created a table, and this is a confusion matrix table of all the 10 classifiers. As you can see, weighted voting, XGB, GBC, AdaBoost, and DTC, they all have high true positives and true negatives compared to the other algorithms. Furthermore, they have lower false negatives and false positive values, which is very good. For example, if you look at logistic regression, it has pretty high false negatives and false positive. For example, even if you look at SGD, it has high false positives here. Next, they created a table 2, which is just basically a classification report of all the 10 algorithms that they use. You can see that the weighted voting had the highest accuracy amongst the other ones, which had an accuracy of 97%. They had an AUC of 0.93. Quickly, the AUC just means that it just basically just it's just a classification ability just to discriminate between the classes. If AUC is 1, all positives and negative class points can be properly distinguished by the classifier, right? So the closer to 1, the better. The farther away from 1, the worse. The model with the lowest accuracy was SGD of 65%, and you can see that it had pretty low precision, had a high recall, but when it had stroke, the values were pretty bad. But for these bottom four algorithms, the precision, recall, F1 were all relatively high. Now on to the right, figure 3 just shows the false positive and false negative rate of the different classifiers. Right, the higher the FN rate indicates false alarms which are created by the model. In terms of the false positive rate and the false negative rate, the figure 3 indicates the relative success of the classifiers. So the best predictor among the selected techniques is weighted voting. Right, you can see that SGD had a very high false positive rate. But nonetheless, weighted voting had the lowest false negative rate and false positive rate, which is really good. The performance evaluation revealed that weighted voting provided the highest accuracy of about 97% compared to the other machine learning classifiers, and as a result, weighted voting can be considered for the prediction of stroke. Some criticisms that I have, first I'll go with the positive, is that the research used and applied many popular machine learning classifiers. It was good to see that they just not cherry pick a few of them, they use all of them. Rather the most popular ones. On to like the negatives. Some negatives I have is that although they use very popular classifiers, machine learning classifiers, they forgot to use SVM. I would have liked to see how SVM played a role and if it did better than the other ones, than the other classifiers. Another thing that I have is that the confusion matrices and measurement results should have been displayed using a cluster column chart instead of tables. I feel like they could have done a better job on the visuals. Finally, the application to my project, I basically got a really good insight into the various ways of comparing classification reports and comparing and contrasting the models. But the main takeaway, since I'm dealing with a classification project, right? I think it's a good idea to use weighted voting by aggregating the results of base classifiers. So I should have lots of classifier algorithms so that I can reach the highest level of accuracy. And one other thing I should think of implementing is having another performance evaluation like that of AUC. That is the end of my slideshow. Thank you.